everyone, it's Justin again. Mia and I are gearing up for an epic road trip to the Grand Canyon. We'd also like to stop at Dinosaur National Monument on our way there. It's going to be a lot of driving, but the sights will be amazing. Before we hit the road, though, we're going to work together to divide up the miles and map out a plan. By the end of today's lesson, you'll be able to use the partial quotient strategy to solve multi-digit division problems. Have your guided notes ready? And let's hit the road. Before we start dividing up the miles of our trip, we need to make sure everything fits in the car. Mia and I have 51 items to pack and 3 storage bins to fit them into. We need to split this total amount into 3 equal groups, or 51 divided by 3. One way to figure out how many items can fit in each bin is by using repeated subtraction. But subtracting 3 at a time from 51 would take a while. What if we subtracted larger chunks of 3 at a time instead? Could we subtract 10 groups of 3 from 51? Well, 10 groups of 3 is 30, so yes, we have enough to subtract 30. 51 minus 30 equals 21. How many groups of 3 can we subtract from 21? Well, we know 3 times 7 equals 21, so we can subtract 7 more groups of 3. 21 minus 21 equals 0. Since we can't subtract any more groups of 3, we need to add up how many groups of 3 we subtracted in total. 10 groups plus 7 more groups equals 17 groups of 3. So to divide our 51 items into 3 bins, 17 items can fit in each bin. This strategy of subtracting groups, or multiples, of the divisor is called the partial quotient strategy. It helps break the dividend into smaller, more manageable parts to work with. There's a lot of flexibility when using partial quotients because you can use facts you already know to solve the problem in a way that works for you. We can set up our work using the long division symbol to keep everything clear and organized. Here's how it works. First, we place the dividend, the total number we're dividing, which is 51, inside the symbol. Next, we place the divisor, the number we're dividing by, which is 3, outside the symbol, here on the left. The space above the symbol is where we're going to record the quotient, or the total number of groups of the divisor, which is the answer to our division problem. To keep track of my work, I like to draw a vertical line next to the long division symbol. This separates the partial quotients from the subtraction. Okay, on the right side of the vertical line, we can record the groups of 3 that we subtracted. And under the long division symbol, we'll show our subtraction steps. Notice how the number of groups we're subtracting are in line with the amounts being subtracted. Lining them up this way can make it easier to double check our work. This matches the work we did before, but the long division symbol helps us organize everything in one area. Try using the partial quotient strategy to solve this part of our trip. We'll be driving 260 miles from Miaville to Dinosaur National Monument. If we plan to drive for 5 hours, how many miles will we travel each hour? We need to divide 260 by 5. And we can use the partial quotient strategy with the long division symbol. Think of some larger multiples of 5. What would 10 groups of 5 be? 50. What about 20 groups of 5? Well, 2 times 5 is 10, so 20 times 5 would be 100. We can use these facts to help us as we solve. Let's start with 20 groups of 5. We'll record that to the side here. 20 groups of 5 is 100, which we'll subtract from 260. 260 minus 100 equals 160. We'll record another 20 groups of 5 to the side here. 160 minus 100 equals 60. Continue subtracting groups of 5 from 60 until you reach 0. Pause the video here to record your thoughts. We could subtract 10 groups of 5, which is 50 miles. So 60 minus 50 equals 10. 2 more groups of 5 is 10. So 10 minus 10 equals 0. Adding up all the partial quotients, or the groups of 5, will give us our total quotient. 20 plus 20 plus 10 plus 2 equals 52 groups of 5. We'll drive 52 miles each hour. The best part about the partial quotient strategy is that it's really flexible. You could solve the same problem in different ways depending on which facts you know. Check out how Mia solved it. Instead of doing 20 groups of 5, she started with 40 groups of 5, which equals 200. 260 minus 200 equals 60. And then she did 12 groups of 5, which equals 60. 60 minus 60 equals 0. Notice how we both got the same answer, 52. The next part of our trip is 1,104 miles. We'll split this distance over 3 days. How many miles will we need to drive each day? Pause the video here to practice using the partial quotient strategy to solve 1,104 divided by 3. It might be helpful to start by listing some larger multiples of 3, like 100 groups of 3 or 300 groups of 3. Remember, you can choose the multiples of 3 that you want to work with, so you might have subtracted different groups of 3 than I did. And that's totally okay. I started by subtracting 300 groups of 3, which is 900. 1,104 minus 900 equals 204. Then I subtracted 60 groups of 3, so 204 minus 180 equals 24. Next, I subtracted 8 groups of 3, so 24 minus 24 equals 0. We can't subtract any more groups of 3, so let's add up all the groups. 300 plus 60 plus 8 equals 368. That means we'll need to drive 368 miles each day. Did you use the same groups of 3 that I did? Or did you come up with different groups to subtract? There's no single correct way to break apart the dividend. As long as your partial quotients add up to 368, your way works too. So, what have we learned today, besides the fact that Mia and I have a lot of driving ahead of us? Well, now you know that the partial quotient strategy breaks large division problems into smaller steps by subtracting multiples or groups of the divisor. Be sure to complete the practice questions and extension activities that go with this lesson to practice using the partial quotients strategy. And remember, mathematicians, in math, as in life, every effort adds to your success. I'll see you next time.